Hello everybody. Today we are going to solve Leetcode question 1261. Find elements in a contaminated binary tree. So we are given a binary tree with the following rules. The root dot value is 0. If any node has a value and has a left node, then the left node's value will be 2 times x plus 1. And if it has a right node, then the right value will be 2 times x plus 2. Now the binary tree is contaminated, which means all the values have been changed to -1. We need to implement a class, uh, and we have to recover the binary tree. Once we have recovered the binary tree, we have to return true if a value target is present in the tree or not. Okay, let's take a look at some examples. We are given this example, -1, which has a right node, -1. So as we know, the root node will always be set to 0. So the root node is set to 0. The left, we do not have a left node, we have a right node. So the right node will be set to 2 times 0 plus 2. Value will be 2. Okay, so we have recovered now the binary tree. Now we are told to find if the value 1 is present. So we are given the value 1 and we have to return a boolean. So we check in the binary tree, the 1 is not present, so we can return false here. And again we are told to check if there is a 2 present in the binary tree. There is a 2 present, so we return true. Okay. Similarly, we have another example wherein we have the binary tree -1 as a left node, as a right node, as a left node, as a right node. So this binary tree will effectively be changed to 0. Left node is 1, the right node is 2. Then for 1, the left node will be 2 times 1 plus 1, that is 3, and 2 times 1 plus 2, that is 4. Okay. So once we have changed this, we are told to find the values 1, 3, and 5. So we know 1 is present in the array, so we return true. Now 3 is present in the array, we return true. And we know 5 is not present, so return false. So the naive approach would be to generate the to convert the tree, right? To convert this tree to a binary tree. And then for each given value, we start from the root and traverse and try to find if the value is present in the try to find if a value is present in the tree or not, right? Um, Thinking of optimizing, because we are already going through the tree and setting the values, we can store these values in a set, and then we can just look up in the set if a value is present or not, right? That will be much quicker. This will work because we know the relation between the root and the left and right childs, right? The time and space complexity of this will be, we will take off n time because there are n nodes to be parsed, and we will take off n space because we'll also keep a track of all the numbers that are there so that the lookup will be quicker, one time. Let's implement it. So we will need a set to store the values, right? So we'll just create a lookup set, hash set, right? Initialize it to be an empty set, and then we just call the DFS function, right? So we just call a function DFS, we return the root, we pass in the value 0. And because 0 is the initial root value, let's implement the DFS function. Takes a root and it takes in a value. So if the root is empty, we do not have to do anything, we can just return from here. Otherwise, the root has a value and we know the value of that root will be the value we have passed. So we'll just lookup dot add value. So we'll just add this value and we will call the left and right calls. So self.dfs dot left. The value of the left node will be 2 times value plus 1, and self.dfs root.right. The value of the right node will be 2 times value plus 2. This will take care of adding the value to the lookup if it is present, and then it will again go to the left and right nodes if they are present. Okay, so now in the find method, we just have to check if target is present in the lookup table or not. So we can just return target in self.lookup. Okay, this looks good. Let's try to run the test cases. Okay, test cases are running. Let's submit. Accepted. Thank you.